So the fourth exercise in trigonometry deals with trigonometric identities. There are three main trigonometric identities, which are basically equations that have been derived and kept for our usage. The first one is sine square theta plus cos square theta equal to 1. It can also be told as sine square a plus cos square a equal to 1, or sine square c plus cos square c equal to 1. Only condition is that these two angles should be the same in order to apply this identity. So that's why we can use theta or a or b or whatever. So now, first and foremost thing that you have to understand from this equation is you should be able to change this equation according to the question and still able to get some answer. What I mean by that is, from this equation, sine 1 minus sine square theta will be cos square theta. So this understanding we should have, like how it will change if you bring it to the other side and all of that. For example, here we have sine square theta. If it is brought to the right hand side, you will be getting 1 minus sine square theta. Like if we reorder the terms, how does it change? That's very, very important. So if sine square theta comes to the right side, you get 1 minus sine square theta, which will be nothing but cos square theta. Similarly, 1 minus cos square theta will be nothing but sine square theta. So this cos square theta will come here. So you get 1 minus cos square theta. What you are left with is sine square theta. So it is the same equation. You should be able to interchange in order to get the result. You will understand this when we do problems in exercise 8.4. Likewise, the second identity is called 1 plus tan square theta equal to sec square theta. Third identity is called 1 plus cot square theta is equal to cosec square theta. So with this understanding, and also we need to be able to interchange these terms and still able to derive an answer. So we will be applying this in the problems in exercise 8.4. Now let us try to understand the first question. Express the trigonometric ratios sin A, sec and tan A in terms of cot A. So what they mean by that is, we have to equate sin A, sec and tan A, all three of them individually, such a way that we get only cot A in the right hand side. That cot A can be of any form. It can be the denominator, numerator, in square roots, in squares, whatever it is, positive, negative. But we have to represent sin A only in terms of cot A. So now let us approach this one by one. So first I'm approaching sin A in terms of cot A. Now, if we try to directly connect and see whether there is a relation between sin A and cot A, we don't have a direct relation between sin A and cot A. Whereas we have an equation which is 1 plus cot square A equal to cosec square A. So some of you might be wondering, how is it related? So cosec is nothing but the inverse of sine. So we can try to bring it in that way. So now we take an identity, a trigonometric identity, which is the third identity, which is 1 plus cot square equal to cosec square A. So thereby I'm able to bring an element of cot A. But we are supposed to represent it as I represent sin A in terms of cot A. So what we do here is, we are not going to disturb the cot term, which is 1 plus cot square A. In the right hand side, cosec square A can be written as 1 by sine square A. And this is because we know very well that sine is the inverse of cosec. So cosec A is 1 by sine A, cosec square A is 1 by sine square A. So we are supposed to find sine A. So sine square A goes here, 1 plus cot square A comes to the denominator. We are just interchanging the terms. So now this will become sine square A equals 1 divided by 1 plus cot square A. This is what we are getting. But we are supposed to equate sine A, not sine square A. So when you make this sine square A sine A, we take root in the right hand side, like this. Because see, if you look at this, how I have reduced it, the square has been removed, which means in the right side you should take a root, I mean the whole root. Now this is what you get. Now we know that this root can be distributed across the numerator and denominator. So root of 1 in the numerator will become 1 and the denominator will be root of 1 plus cot square A. So some of you might be wondering if I can cancel this root and the square. We can't do it because there is a plus 1 that is associated over here. We can do this if there was no 1 plus. we can directly cancel this root and square. But here there is a 1 plus, so we can't cancel it off. So this is the answer for the first part. So what have I done? I have represented sine A in terms of cot A. There is nothing else. If you look at it, there is nothing else on the right side. But how I have represented, there is a square, there is a root, that doesn't matter. So this is how we approach the first subdivision. Now let us try to understand how we will be able to write CK in terms of cot A. So when I say CK and cot A, there is again no direct relationship between them, but there is an identity which is called 1 plus tan square A equal to sec square A. So some of you might be wondering how this identity is helpful. That is because tan is nothing but the inverse of cot. So we can actually bring it over here. So what I'm going to do here is I'm taking this identity, which is the second identity, and I'm equating tan square A. So this will become sec square A minus 1. Or you can just have it as such. I would say you can just have it this tan square A, you can convert it as 1 by cot square A. We all know that the inverse of tan is cot, which is equals to sec square A. Now, when you take the LCM, you get sec square A equal to cot square A plus 1 divided by cot square A. I'm repeating the steps. I have taken the second equation, which is nothing but 1 plus tan square A equal to sec square A. Why I have chosen this equation is because in the question they have asked us to equate sec and cot, the second part of the question. So sec is very well here, but tan can be brought in by introducing the inverse of tan. I mean, cot can be brought in by introducing the inverse of tan. So we are able to write tan square A as 1 by cot square A. As we all know, that is the inverse. So now I'm taking LCM here. LCM step is nothing but you have a by 1 here. So here I'm multiplying cot square A. In the numerator also I'm multiplying cot square A. Since this is the denominator, I'm multiplying it with the 1 with cot square A in the numerator and denominator. Now this will become, in the numerator you will get cot square A plus 1, and in the denominator you will get cot square A. That is the LCM step. LCM part is very important. Now we are not supposed to find sec square A. We are supposed to find sec A. Now sec A becomes root, as we did in the previous step. So root of cot square A plus 1 divided by cot square A. This is the step we are getting. Now, as we all know, this root can be taken separately, the numerator as well as denominator. So you'll be getting root of cot square A plus 1 divided by root of cot square A. Now, interestingly, if you observe carefully, it's very obvious that this root and this square will get cancelled, but the root in the numerator and the square will not get cancelled. This cannot be done. That is because of plus 1. There is another term which has been associated. So this root and this square will get cancelled, and you will be getting the final answer as sec A is equal to root under cot square A plus 1 divided by cot A. This is because the root in the denominator has got cancelled. So this is the final answer, and you can see very clearly that I have represented sec A, which is the left hand side, in terms of cot A. There is only cot A, but of course it's there in the numerator as well as denominator. That doesn't matter. So this is how we do the second part of this question. So the third part is we are going to represent tan in terms of cot A, and we need not actually go to any identity for this because we know very well that tan A and cot A are inverse of each other. So we can directly write tan A equals 1 by cot A, because we know that they are inverse of each other. So we are able to express tan A in terms of cot A as an inverse. So this is quite simple, unlike the other two. So this with this we come to the end of first question. So the second question is also quite similar. They have asked us to represent all other trigonometric ratios in terms of sec. So what they mean by that is, we are in the second question. So except sec, what all the other trigonometric ratios we have? So basically we have sin A, we have cos A, we have tan A, we have cosec A, and also we have cot A. So we have to represent all these 5 trigonometric ratios in terms of sec. This is what we are going to do now. All the other five in the sense except sec A, all the other 5, sin, cos, tan, cosec, and cot, we are going to represent it in terms of sec. That is what we are going to do now. And some of these will be very simple, and some of them will require some more steps to do. So we look at it one by one. So let us approach this one by one. So firstly, there is no direct relationship between sin A and sec, but we have an indirect relationship wherein sin square A plus cos square A is equal to 1. This is the first identity. So how is this related to this particular part is, of course, we have sin A, and cos can be written as 1 by sec square A. That is what is asked in the question. So we will be able to write cos as the inverse of sec. So now in the next step, we can write sin square A is equal to 1 minus cos square A. We'll be able to write like this. Or you can convert it as sec square A, and then also you can take it to the right side. That's completely up to you. So I'm doing it this way. So sin square A equals, so you'll be getting 1 minus, our very idea is to represent it as sec. So therefore we are writing this as 1 by sec square A, because we know cos and sec are inverse of each other. Now in the next step, we are going to take the LCM. Now you get sec square A minus 1 divided by sec square A. This is the LCM. Because here you have by 1 into sec square, so you get sec square A minus 1 by sec square A. Now we are supposed to get sin A, not sin square A. So we take a root in the right hand side. So it becomes whole root of sec square A minus 1 divided by sec square A. Now, as we did the previous problem, when we take the root separately to the numerator and denominator, we finally get sin A equals, the numerator doesn't change because there is a minus 1 associated over there. So we get sec square A minus 1 root. But in the denominator, when we take the root and sec square get cancelled. So we get only sec A. So this is how we approach the first part of this particular question. Now let us try to understand the second part. So the second part is basically representing cos A in terms of sec A. So how are we doing it? It's basically direct application. We know that cos is the inverse of sec. So that's it. So this is quite direct because we know that cos and sec are inverse of each other. So this is about the second subdivision. With respect to the third subdivision, I would like to show it here, the third subdivision. So third subdivision, how am I able to write tan A in terms of sec A? There is a direct equation involving both of them, which is 1 plus tan square A is equal to sec square A. So this is an equation that involves both of them, that is tan and sec. Now we are going to equate tan from this. So you'll be getting tan square A is equal to sec square A minus 1. So first we have sec square A, and then only 1 goes to the right side. So the minus 1 will come at the end. And actually we don't require tan square A, we actually need tan A. So tan A is nothing but root under sec square A minus 1. And that's it. So this is the answer for the third part. So we are able to write tan A in terms of sec A. Now let us try to understand part D and E, that is fourth and fifth part. So they have asked us to find cosec A in terms of sec A. This is quite easy because we already found, done sin A. So if sin A, the answer for sin A is somewhere here. If you look at the screen, it is somewhere here, the green tick. So now, if that is sin A, then cosec A will be completely inverse of that. So cosec A will be, denominator comes to the numerator, which is sec A, and numerator comes to the denominator, which is root of sec square A minus 1. So this is how we get the last part. So this is something that we need to know. So cosec A can be found easily because we already have the value of sin A. So you have to completely do the reciprocal. So sec will go to the numerator and sec square A will minus 1 will come to the denominator. So that's how you get this answer. Likewise, the last part also, that is cot A also, we've already got tan A here. Please look at the green tick now. Yeah, so we've already got tan A. So cot A is nothing but the inverse of tan A. So cot A will be 1 by root of sec square A minus 1. again the reciprocal of this. So basically tan A is like root of sine square A minus 1 by 1, root of 6 square A minus 1 by 1. So when you reciprocal it, you get like this. So these are the other two. So likewise, we have done all the five, we have expressed all the five trigonometric ratios in terms of CK.